Um, all right, welcome back to Econ. Hope you had. I hope you had a good hour off if you were in finance with me, and hope you had a good day off if you're not. I ran downstairs and made some spaghetti sauce for dinner. We're gonna have pizza tonight, so that was what I was doing in between classes. So for today, I just want to kind of say I would like to talk again to the HMP students at the end of the class, just for a couple of minutes about what's going on with internships. So I'll give you kind of an update as to where we were at. We had a long meeting yesterday, so things are cooking along there. All right, real quick. Just want to show you some of the stuff I've posted in case you didn't see it. So here's our Canvas site. So for chapters 11 and 12, I felt like you guys maybe needed a little more help with the calculating marginal cost. So there's a marginal cost video, how to do marginal cost. It's basically how to take a derivative. Then there's a quiz, so you can practice taking the marginal cost. Then there's a second video on how to find the profit maximizing quantity, as well as the maximum profit. So that's worth looking at because there will be questions on that on the exam. Then some more practice questions on how to find finding the profit maximizing quantity, as well as finding the profit maximizing, rather the maximum profit. I posted the lecture from from Monday afternoon. So that's here. It's on a private YouTube post. I scanned in the lecture notes, so my scribbling on that you saw in the document camera. I shared or scanned those in. So if you're watching the video, you can also look at my notes if that's useful to you. And then this morning, I decided I was thinking that maybe a little bit of fuzziness on all the curves and moving the price up and down, and how that affects the shutdown conditions. So I made a 15-minute video going through that in some detail, using PowerPoint rather than using my messy writing, which maybe contributed to maybe some of your confusion. Even though most of you said you got it, I'm suspecting that some of you at least did not. So if you're feeling uncomfortable with that, you should go ahead and watch that video. There will be questions about that on the exam as well. All right, and then I owe you some practice problems, and I have not had time, so I'll try to do it either tonight or tomorrow for sure. I'm gonna time myself to say by the weekend you'll have them to work on. So there's that. Okay. Okay, so we're going to move into chapter 13 for the next two classes. And so chapter 13, we're going to move from talking about the perfectly competitive market, which is kind of an extreme example on, kind of on this side, to a monopoly, which is kind of an extreme on the other. So the assumptions with the perfectly competitive market is that you have lots of small suppliers that are theoretically identical, so they all have the same cost structure, and you have lots of small buyers, none of which on either side are big enough to influence the overall market. And so the buyers and suppliers both face a perfectly elastic supply curve that none of them can influence. And so the suppliers are price takers, which is a phrase that we used in Finance 1 that you should remember. And all of their calculations that they do are based on the assumption that the price is given, and they make adjustments accordingly. The assumption, on the other hand, now we're going to talk about monopoly. And monopoly is kind of the opposite assumption. Here, with a monopoly, you have many small buyers. So that's still true from the original assumption. but then you have only one seller, right? So if you think about a monopoly, you might think of in your lifetime, there aren't as many as there were back in back like when I was your age. So back when I was your age, before cell phones, you used to have this thing called a home phone, and everybody had one because you didn't have cell phones, and you had to buy phone service, and you bought phone service from your local phone company, and that was the only that was there was only one local phone company in the United States. There was always only one local phone company. There was no competition. So for your local phone service, so like if you were going to be calling, if I was living in Durham and I wanted to call Dover, I pick up the phone, right? And I dial in the phone number to call Dover, and I was on the local phone lines. And there was some area within which you had kind of unlimited ability to make phone calls. And then if you wanted to call, let's say, I wanted to call Exeter. Exeter might be outside of my so-called local phone service, and so then I would have to pay, say, 20 cents a minute to call down to Exeter. And there was no competition for that. The only competition you had was long distance calling, and I forget what the parameters eventually be. Originally there was no competition long distance either. AT&T had the entire market for all phones, right? And then eventually they broke up AT&T, the local phone, into local phone monopolies. And then eventually we had long distance competition. So my wife and I, back, I don't know, all the way up till the early 2000s, we used to periodically shop for different long distance providers. And we could change, providers, but you were basically stuck with the same local phone company. And so you'd shop and see, well, who's going to give me the cheapest phone calls to call from Texas back to New Hampshire, which is, a lot of what we were doing back in the day. But you would always have this local phone company that basically just got to set the price. Whatever the price was going to be, they got to set the price. So that's a monopoly, right? That's an example of a government mandated monopoly. Not only was there were elements of a natural monopoly, and we'll talk about that in a minute, but it was against the law to try to provide local phone service, in competition with the local phone company. So they had both a legal monopoly as well as probably a natural monopoly in a lot of cases. So monopoly, you can think about, is one seller and many small buyers, and the one seller gets to set the price of the goods and services. So that's a monopoly. And so a monopoly is kind of an extreme opposite example from what we've been working with in chapters 11 and 12. And the reason we work with these kind of extremes, and both of them are somewhat, they're both extreme, right? So it's useful to kind of look at two extremes. And then when we get to oligopoly, we'll look at something kind of a little more in the middle. And I would say that there are very few businesses that operate in the perfectly competitive environment. There are very few businesses that are actually in the monopoly role. A lot more sort of in the oligopoly range. So today we're going to talk monopoly and start making some comparisons between them. The main thing that we have to remember is, or the main term that you're going to want to kind of keep in your head, is this idea of market power. And to refresh, market power just simply means that a buyer or seller has the ability to influence the price of the goods and services in the market. Okay, so let me switch to my document camera now so I can start doodling a bit. And again, let me know if we're out of focus. Let me see, I'll get it a second to. Okay, shout at me. I'll try to keep watching for the for chats, but if I go out of focus, go ahead and unmute and shout at me. Okay. So our assumption with the perfectly competitive, right, was that we had a perfectly elastic demand curve, right, where demand is equal to price is equal to the marginal revenue. Because how much more revenue did you get if you sold one more? Well, you got the price. So you got one more at whatever price is equal to. So if price is 10 and you went from selling 10 to 11, you got one more unit at a price of 10. If you went from 11 to 12, you got one more unit at a price of 10 all the way along, right? And so the sellers in the market had some marginal cost curve that they applied, and to find what their profit maximizing quantity was, you apply their marginal cost curve against the demand curve, which is also equal to the marginal revenue, so that you could find the point where marginal revenue equals marginal cost, and that was their profit maximizing quantity, right? So that was what we've been working with. Now we're going to move into a different assumption. And this assumption is, again, now we're going to assume that there's, for whatever reason, one big seller in the marketplace, and that seller is so big that they can supply the entire market. So it's possible for them to provide all of the services, goods or services that are desired in the market. So if this is the market for physician care, this is a physician practice that's capable of taking care of all of the entire population of your town, right? So they would have they have the capacity to do that and more, right? And so because they have so much capacity, uh, um, they're going to be capable of deciding how much quantity to provide in the market, and as a result, they will face a decreasing demand curve. So we're going to go back to the kind of the demand curve that we had been working with at the beginning of the class. So now we have a falling demand curve, right? So we have price and quantity. And it's not now true that demand equals price equals the marginal revenue, right? So price happens all along the curve, different prices for different quantities. Monopolists are now able to, whereas in the perfectly competitive environment, price equals marginal revenue equals marginal cost, and so therefore price is equal to marginal cost. In the monopolistic market, price is going to be greater than marginal cost. However, marginal cost will still equal marginal revenue at the profit maximizing quantity. So when a firm is large relative to the market, it can influence the price in the market by deciding how much quantity to bring to market. And when it has that much capacity, if anybody else tries to enter the market, they just flood the market with more quantity, right? So if somebody tried to set up, so let's say we have a big physician practice in our town, and it's got the capability of providing all the services that we could potentially need in our town. Imagine some sole provider tried to come in and set up a family practice. Conceivably, that monopoly provider could then reduce the cost of family practice, could just provide more family practice visits, so much so that the price of family practice visits fell and basically pushed the new entrant out. And so that's what monopoly can do, right? Monopoly just keeps on cutting price until all of the other possible competitors just leave. But then at that point, it raises prices again. And we'll get more into that when we get into oligopolies. That's a little more oligopolistic competition. But the thing you have to remember is under monopoly, the monopolist faces a downward sloping demand curve. Under perfect competition, the suppliers face a horizontal or perfectly elastic demand curve. Okay. So as the monopolist decides to increase quantity, right, say from P1 or Q1, they get P1. If they increase quantity to Q2, then price falls to P2. So the monopolist gets to choose what quantity he or she wants to put, or it wants to put onto the market, such that they get a profit maximizing price and quantity. Okay. Now, under perfect competition, total revenue is simply price times quantity, and it is literally just price, which is a fixed number. So this P is always going to be some fixed number times whatever the quantity is, right? So that's going to be the price is fixed at, say, 10 or 20 or 1,000, whatever that might be. It's always, the fixed price. That's the nature of a perfectly competitive market. So regardless of how much quantity is put out into the market, the price is always the same. So it's simply P times Q. So if the price is 10, then you'd get, the total revenue function would simply be 10Q. Over here, the price function, right, is the inverted demand curve. So it's going to be something like P equals, say, 10 minus Q, right? That would describe this curve pretty well, where, our maximum price, our y-intercept price is 10, right? And it goes down at a slope of -1. So it goes down. So for every additional unit of Q, so if you make Q is equal to 1, then you get a price of 9. If Q is equal to 2, you get a price of 8, and so forth. So P is not a constant number for the monopolist. It's a changing number depending on the quantity, as opposed to over here, it's always just 10, right? Or it's always 25 or whatever it is. Over here, it depends on how much quantity the monopolist wants to put into the market. So total revenue is still P times Q, right? Except that P is not a constant number. P is actually this, right? So P times Q is actually 10 minus Q in this case times Q. So you're going to want to know, when you look at a monopolist and you're looking at their demand function, you're going to need to know what's the inverted demand curve, because that's going to tell you what the price is going to be equal to, right? Remember, this is our inverted demand curve because it's set as P equals 10 minus Q. Our standard demand curve is Q is equal to some function of P. So you're going to be inserting the expression for P. In this case is 10 minus Q, but it could be 20 minus 1/2 Q, or 1,000 minus 37Q, or something like that. Whatever it is, you're going to need to know that to be able to plug it in for P. And then when you multiply that through, you're going to wind up with 10Q minus Q squared. So total revenue now is going to be under the excuse me, under the monopolist, the total revenue function is going to be an exponential function, sort of like we did with the perfectly competitive total cost. So let me see if I share my screen with you. We can do a quick example. Oh, that's you guys. Let me get a new file. All right. So if we set up our example here, let's say that we have Q, and then we have P, right? And then we have total revenue. So let's say we start with 0Q, 1, 2, 3. I'm just going to set it up. We're going to use the same function I just did. So I'm going to get that to 10. All right. And then price, right, was equal to 10 minus Q. So I'm going to do 10 minus whatever the Q value is. So at a quantity of 0, the demand for the quantity is 10, or the willingness to pay is 10. So, but at a Q of 0, of course, you're not going to have any revenue because you're not selling anything. But now I can copy this down. And so we had our price. Our price is a function of quantity. So it's 10 minus the amount of Q, right? So that's the inverted demand curve that we worked before. So when Q is 0, price is 10. When Q is 1, price is 9, and so forth. It goes down, right? Total revenue is price times quantity. So what we can see is initially it's 0, then it increases to 9. At 2, it goes to 16 and so forth, and it hits 25, and then it starts to come back down again. So I could graph this by highlighting these two columns and then hit insert line function. I don't need that. So my graph of my total revenue in this case then is it initially rises, it hits a peak at really at about 5. This is not capturing the right information. And then it falls. So this should be running 0 to 11 rather than, let me see if I can fix it. There we go. So now you can see at 0 quantity, we get 0 revenue, and then it rises, up to a peak at 5, and then as we approach 10, it falls back down again. So what's happening? Well, as the monopolist raises their price, as the monopolist increases quantity on the market, they have to cut their price, right? So if they want to sell 1 unit, they can't charge 10, they actually have to charge 9. If they want to sell 2 units, they have to charge 8 for both units. This is an important point that I want you to kind of remember. It is that they're not getting to sell the first one for 9 and the second one for 8. If they want to sell 2, they have to charge 8 for both. If they want to sell 3, they have to charge 7 for all 3. If they want to sell 4, they have to sell all 4 at 6. They don't get to charge 9, then 8, then 7, then 6. We're actually going to look at that very shortly, and that's called price discrimination. But for right now, what we're assuming is the monopolist picks a price and sells all of its quantity on the market for that price. So if it chooses a price of 9, it's going to sell 1. If it chooses a price of 5, it's going to sell 25. So as it increases its quantity, it has to start cutting its price, and it keeps cutting its price. As it cuts its price and increases its quantity, initially it sees more and more total revenue coming in. But then it reaches a point where in order to sell a 6th unit, it actually starts to lose money. And so what we're seeing here is the marginal revenue, right, is also changing, right? So how much more revenue do they get from selling? What's the marginal revenue at 1 unit? Well, it is approximately 9 minus 0, or 9, right? And then the marginal revenue at 2 is an additional 7. And we can go down here and at 5, it really should be 0, but this is really an approximation. But you can see when we cross from 5 to 6, the marginal revenue actually is -1. So by going from selling 5 to selling 6, total revenue actually starts to go down. So the marginal revenue actually becomes negative. So let me draw this. And so it progressively goes back down again. So if we were to add this to the graph, let me see, add MR. What you see is um, it goes, you can see this is the 0 line, it actually goes negative, right? The marginal revenue starts high and starts to go down. And then when the total revenue is at its maximum, the marginal revenue hits 0, and then it goes negative along with the total revenue starts to go down. So when marginal revenue hits 0, that's actually when you're going to have um, the highest total revenue, right? Now, remember, the marginal revenue is actually the slope of this curve. So the slope at the top of a curve like this is going to be a flat line. All right, so if I was to, let me draw what I have up on the board now, it's easier for me to do it visually. So if this is my total revenue curve, right, the slope of the total revenue is my marginal revenue at any given point, at any given quantity. And so at the top of this curve, if I'm bringing in a flat, if this was a ruler, I was bringing a flat ruler, at any given point on this curve, right, just like with the cost curve, my pen is going to is going to have a tangent point where it just barely touches, and it's going to touch at one point. And so as we go up the total revenue curve, the slope of the tangents are all positive because they're going up and to the right. When we get to the very top of the curve, the tangent is going to be perfectly flat. In other words, the slope of that point is equal to 0. And then when we cross that point, so at that point, MR is equal to 0, right? Which corresponds with what we visualized here, right? So the MR at 5 hits the 0. So at the top of the total revenue curve, the marginal revenue hits 0. So at this, whatever this quantity is, in this case, it's 5. The marginal revenue is going to equal 0, and the total revenue is going to hit its maximum. And then once we cross 5 and start down the slope, right, we're going to see downward sloping tangent lines, right, which means that in this case, marginal revenue is less than 0. So as we approach the peak, marginal revenue is greater than 0. At the peak, marginal revenue is equal to 0. And once we cross the maximum quantity, the quantity that generates the maximum total revenue, then marginal revenue is going to be less than 0. So it's going to start going down progressively. Okay. So the function for this curve, then, as we said, was total revenue equals 10Q minus Q squared. So the marginal revenue then would be this. We would find the same way that we were looking for the marginal cost, right? So the process that we did, just to refresh, is we look at the exponent of the first term, and the exponent for the first term is really 1. So that 1 comes down. Then we bring down the 10, the coefficient. Then this becomes 10 to the Q 1 minus 1. right? And then we can keep going and we say minus, and we bring down the coefficient or the exponent for the 2 to q to the 2 minus 1. So q to the 1 minus 1 is q to the 0. Anything to the 0 is 1. So we really have 1 times 10 times 1. So that's just 10. Q to the 2 minus 1 is q to the 1. So anything to the first power is just itself. So we really just have 2q. So MR equals 2q. And so when marginal revenue, if we want to find the maximum total revenue, right, is where MR equals 0, because we said it's going to be where the tangent line is flat. The tangent line is where MR is equal to 0. We can just set the marginal revenue equal to 0. So we'd get 0 equals 10 minus 2q. And solving that, we get q is equal to 5. So if you want to find, you're going to need to be able to find the marginal revenue, because we're kind of not done yet. We are interested in where total revenue is maximized, but what we're really interested in is where the monopolist actually makes their maximum profit, right? So not so much, we're less interested we are less interested in where they maximize their revenue and more interested in where they maximize their profit. But you'll need to be able to find marginal revenue in order to solve that, because we're going to want to be able to say, okay, MR is equal to MC at what quantity? So we'll get to that in just a second. But why does marginal revenue decrease? Well, it seems, so just to refresh, to remind, or to reiterate, I should say, sorry, okay, I think you're seeing my screen again. It's hard for me to tell. But right, marginal revenue is going to keep going down, because in order to sell more, right, so initially as they sell more, they make more money, but in order to keep on selling more, they have to keep cutting price, right? So they progressively cut their prices, and eventually as they cut their prices, they start to lose money. And the key thing here is they can't sell the same thing to different customers at different prices. So if we were to now graph marginal revenue with respect to the price and quantity, so this is the monopolist's demand, right? And we'll use P is equal to 10 minus Q, because it's a really easy function to work with. If we want to graph the marginal revenue now, remember that marginal revenue was equal to 10 minus 2Q. So if we're going to graph marginal revenue on here on the same, on the same axis as price, then marginal revenue would start, if we're setting, so marginal revenue is going to be on the y-axis and Q is on the x-axis, then we can say, okay, when Q is equal to 0, right? When Q is equal to 0, what is the y-intercept for marginal revenue? Well, if Q is equal to 0, you get -2 times 0 is 0. So marginal revenue is 10. And when marginal revenue is 0, right, so we're trying to find the x-intercept. So when marginal revenue is 0, what we said was Q is going to equal 5. So we have the marginal revenue now we can graph as a straight line going down. So this is our marginal revenue curve. This is our, and this is our demand curve. So the marginal revenue curve in this class, because we're going to use linear demand curves, right? So this is a linear, meaning it's straight. The demand curve is always going to be a straight line. So the marginal revenue curve is always going to intersect the, have a x intercept that is exactly halfway to the x-intercept of the demand curve. So when you go to draw or look at a draw and marginal revenue curve, it's going to be inside the demand curve and roughly, and it will intercept exactly halfway between the y axis and wherever the demand curve crosses the x-axis or the x-intercept. Okay. So let's do a quick practice. I'd like you to try. Let's assume that instead of price is equal to 10 minus Q, price is equal to 800 minus 10Q. What would the total revenue function be? So I'll give you a second. When you've got it, throw it up on the chat. Once I see some coming in, I'll keep going. Good, Mary. Yep. Good, Ariana. All right. So I assume a couple of you can see a couple of your colleagues have got it. So total revenue is still equal to price times quantity. It's always price times quantity. But remember, with a monopolist, the price function, the price is not a constant. It's a constant in the, right, in the perfectly competitive environment, price is a constant number like 10 or 47 or whatever it is, right? With a monopolist, the price decreases as quantity increases. So we're going to take this and substitute it in for price. So we'll get 800 minus 10Q times Q. And so then we just multiply the Q through and we get 800Q minus 10Q squared. So that's what you're going to have to do for this chapter. All right. So then if we have that, what is the marginal revenue? So I'll give you a second to work that. Good, Andre. All right, so Andre got it. So marginal revenue, we're going to do the, it's 800Q. Anything just Q is Q to, is implies it's Q to the 1. So we bring down the 1, we bring down the constant coefficient, then we bring down the Q to the 1 and subtract 1. Then we can move on to the next term. So here we have Q to the 10Q to the 2. We're going to bring down the exponent. Then we're going to bring down the coefficient. Then we bring down the variable. And we subtract 1 from the exponent. So MR is going to equal 1 times 800 times Q to the 1 minus 1, which is Q to the 0. So anything to the 0 is 1. So we have 1 times 100, 800 times 1, or just 800. Then we have minus 2 times 10 is minus 20. And then we have Q to the 2 minus 1. So that's q, 2 minus 1 is 1. So we have q to the 1. Anything to the first power is just itself. So we have the marginal revenue is 800 minus 2q, 20q. And the total revenue, well, I messed it up a little bit with the 1 there, but is 800q minus 10q. All right. So the simple rule to remember is that the slope of the marginal revenue curve is going to be twice the slope of the price. Okay. So here the slope of the price was -10, and here the slope is -20. So the slope of the marginal revenue is twice the slope of the price. And that's given that we're always going to work in this class with linear demand functions, right? Straight line. That's always going to be true. So that's a good way to kind of check yourself to make sure that that you've got that your marginal revenue is twice that of the has twice the slope of the price function. All right. So with with this 800 minus 20q price function, or minus 800 minus 20q marginal revenue. So if TR, I'll write this out to be neat, is 800q minus 10q squared, and MR is equal to 800 minus 20q, then what is the revenue maximizing quantity? What quantity will give us the maximum revenue for this total revenue function? So what number are you going to plug in for Q to get the highest possible total revenue? That's right, Andre. All right, giving you a second to think about it. Andre came up with 40. That's correct. Ariana, good. Kat, good, good. So Ariana posted in the chat, you're going to set the marginal revenue equal to 0. So she set marginal revenue, right, is 800 minus 20Q. So 0 equals 800 minus 20Q. And then it's a relatively simple algebra problem, right? That becomes 20Q equals 800. Then you divide both sides by 20, and you get Q is equal to 40. So let's test this. Let's go ahead and put 40 into our total revenue. So total revenue at 40 is going to be 800 times 40 minus 10 times 40 squared. 800 times 40 is 32,000. 40 squared is 1,600 times 10 is 16,000. So you get 32,000 minus 16,000 is 16,000. All right. So you say, that's fine, Professor Bonica. You really haven't proven anything to me yet. So I say, okay. Then let's go ahead and try total revenue is equal to 39. So that would be 800 times 39 minus 10 times 39 squared, right? Well, 800 times 39 is 31,200. 39 squared is 1521, and 1521 times 10 is 15,210. 31,200 minus 15,210 is 15,990. So if we back off, right, and go from 40 to 39, then we are going down by 10 at that point. And if we set total revenue at 41, so we increased by one. So this one we did one less than what Kat and Ariana and Andre proposed as being the maximizing quantity. So we did one less. We saw that we made less than we could at 40. Now we're going to go past 40 to 41. Well, that becomes 800 times 41 minus 10 times 41 squared. 800 times 41 is 32,800. 41 squared is 1,681. So 10 times 1681 is 16,810. 32,800 minus 16,810 is 15,990. So we kind of have what we know is we're kind of at the top. At 40, we're at the top. If we go back to the left, down one, we lose money. If we go to the right one more, we lose money. So our profit maximizing quantity, right? That's not a particularly neat curve, but is maxed out at 40. So if we were to draw the price and marginal revenue, right? We would have, for this function, we would have 800, 80 and then 40 is going to be our, where marginal revenue equals 0, right? Which is also where we said the slope is 0, or in other words, marginal revenue equals 0 at 40. Now, what I said earlier was finding the maximum finding the maximum revenue is interesting and important, but not the most important thing, right? You could potentially be producing the maximum, the revenue maximizing quantity and not be making the maximum profit that you possibly could. So in order to get profit, right, remember profit is total revenue minus total cost. So we're going to go back to our really simple version, which is P equals 10 minus Q. Total revenue then was 10Q minus Q squared. And now we're going to say that total cost is going to be 5 plus Q. And so what we're going to have is a decreasing average total cost. If I was going to graph that, decreasing average total cost, I should say. So if I was going to graph that, right, that 5 plus Q as an average total cost, that's going to be 5 plus Q over Q. So that's going to be the same thing as 5 over Q plus 1. So at Q equals 1, our average total cost would be 6. Then at Q equals 2, right? So Q equals 1, 5 over 1 is 5 plus 1 is 6. So ATC equals 6. At Q equals 2, we'd have 5 over 2 would be 2.5 plus 1 is 3.5, right? And we'd see that continue to go down. So if we were to draw that, what we'd see is something like this, right? And with this total cost function, what would the marginal cost be? Can anybody just glance at that and tell me what the marginal cost is? Good. 1, right? It's the slope of the variable, right? Because the 5 goes away, right? When I say marginal cost, I'm asking you, how much more is it going to cost to make 1 more? Well, to go from um, making 1 to making 2 is going to cost me 5 plus 1 is 6. To making 2 would be 5 plus 2 is going to be 7. So to go from 1 to 2 is going to go from 5 to 6. So 6 to 7, that's a change of 1. If I go from 2 to 3, it'll be 5 plus 3. So making 2 is 7, making 3 is 8. So that's 1. So it's always going to be 1. It's going to be the implied, the implied 1 is there. And so our marginal cost is going to not quite touch that, is going to come out at a value of 1, right? And you're sitting there and you're saying, hey, last chapter you told us that in reality total cost rises, right? It starts low and then keeps going up. And I'll say, or increases. And I'll say, well, so this is the thing about monopoly, right? Is we're assuming that within the relevant range that we're talking about, and the relevant range for the monopolist is the entire market. So remember we talked back in Finance 1 when we were talking about fixed cost. We said fixed costs are fixed for the relevant range. And so your fixed cost fell. Right. Average fixed cost would start high and fall, right? Because over the relevant range, whatever that was. And then it might have, when you hit the end of the relevant range, you might have to buy new equipment, or you might have to rent a new, a larger facility or something like that, in which case then your fixed cost jumps up. Kind of one of the assumptions of monopoly is, again, what I was saying at the beginning of today's class. The assumption is monopolists have so much capacity, they have such a big relevant range, that they always have a falling total cost curve. So their total cost curve goes down. It doesn't then bounce and go back up within the market, right? So within the market, they're basically able to, their costs are always falling, and that makes it really hard. That doesn't, so the fact that their costs are falling instead of rising doesn't create a natural stopping point for them, where where their costs become too great. So unlike our, so that's one of the differences, kind of the differences in the model here is that whereas in the competitive model, we assumed that price equals MR, and MR was constant, and total costs rose and then came back up, and marginal cost came back up. Right here, we're going to assume we'll just make that average total cost. Average total cost is going to fall, and marginal cost we're going to assume is constant in the monopoly model. Okay, so it's kind of, we're kind of flipping, right? We're kind of flipping our assumptions when we move from the competitive model to the monopoly model. So in the competitive model, the price is constant and marginal revenue is constant, and marginal cost and average total cost rise. Under the monopoly model, demand is, and that equals demand, so demand is constant. Under the monopoly model, demand falls, marginal revenue falls, right? And marginal cost stays constant. So like I told you at the beginning, we're working kind of, this was one extreme, and now we're doing a different extreme, right? So the model looks different because we're kind of going to opposite ends of the two extremes. So we'll keep going here. So I said earlier, the monopolist doesn't want to maximize revenue. She wants to maximize profit, right? So she wants to max profit. And so she wants to know, how do I maximize profit? Well, she maximizes profit the same way she would if she was in a competitive market. Maximum profit, right, is going to be where marginal revenue equals marginal cost. So we had, so this is our model of our monopolist, right? So this is her marginal cost. This is her marginal revenue. To find her marginal, to find her profit maximizing quantity, we want to look where the marginal cost line crosses the marginal revenue line, and that's right here. That tells us what quantity the monopolist is going to produce. So she's going to produce at this point. So we're going to draw a line down from that point where marginal cost crosses marginal revenue, and then we're going to draw it up to the demand curve and over to find the monopolist price. So PM is P monopolist, so price the monopolist is going to charge, and QM right here is going to be the quantity that the monopolist produces. Okay, so it's the same idea as before. The monopolist wants to find where marginal revenue equals marginal cost. That determines the profit maximizing quantity. All right, we'll come back to this visualization in a minute. I want to do the math with it instead. So we're still assuming that total revenue equals 10Q minus Q squared. Marginal revenue then, as we already said, is 10 minus 2Q. And we said that total cost is going to be equal to 5 plus Q. And we said marginal cost then is just simply 1. So if profit maximizing quantity happens when marginal revenue equals marginal cost, then we're going to set marginal revenue equal to marginal cost. And so marginal revenue is 10 minus 2Q, and marginal cost is 1. So this one's a pretty simple one. Add 2Q to both sides, subtract 1 from both sides, we get 2Q equals 9. Divide through by 2, and we get Q is equal to 4.5. So if you remember, right, from a minute ago, we said that total revenue is actually maximized at 5. So right here is where the peak is, right, for revenue, right? Revenue is actually maximized at 5, where they're going to make 25. But the monopolist isn't going to produce at 5. She's going to produce at 4.5. That's actually where she makes her maximum amount of revenue. So if we were to draw we now know that her total revenue looks like this, right? At 5. And then we know her total cost curve is 5 plus Q. So that looks like, and this is 25. So 5 plus Q looks something like 5. And then 5 plus Q is going to be a straight line. So it's going to go, let's see, something like this, right? And so, like before, what we're looking for, this is total cost. This is my total revenue. What I'm looking for is a point on the total revenue curve this time that has a slope equal to the slope of the total cost curve. So in this case, the total cost curve has a slope of 1. So I'm looking for a point on the total revenue curve that has a tangent with a slope of 1. So that means, in other words, what that means is I'm looking for where the marginal revenue is equal to 1, which is what I just did, right? I said, okay, I set marginal revenue equal to 1, and then I solve for it. Well, the point where marginal revenue is equal to 1 is a quantity of 4.5. What's the point? This is the point. 4.5 is the point where when we draw the total cost curve, right? Here's our break even, our first break even, right? So at this point, marginal revenue is rising, but prior to the break even, marginal revenue is less than total cost, and so we're losing money. Then we hit the break even, and then total revenue is greater than total cost. And so along here, from the break even point out to the second break even point, we're making profit. What we want to find, though, is the point where the gap between total revenue and total cost is the widest. And that gap is going to be where the tangent of total revenue has the same slope as the slope of the total cost curve, right? And that's going to give us our profit maximizing quantity. Now we can take that and plug it into our profit function. So remember, our profit is total revenue minus total cost. So total revenue is 10Q minus Q squared, minus total cost is plus 5Q. So this is total revenue, this is total cost. So then we just plug in that 4.5. So we have 10 times 4.5 minus 4.5 squared. And then we can distribute the negative. So we get minus 5 minus Q, which is just 4.5. So we get 10 times 4.5 is 45. 4.5 squared is 20.25. And then minus 5 minus 4.5. So if you just add that all up, what you get is a maximum profit of 15.25. All right, so that's a lot. We're doing a lot here, but we've done, all of this really in chapter 11. So what I want you to do now is try to do the same thing with our other function that we were working with, and we said TR is 800 minus 800Q minus 10Q squared. We said that the marginal revenue is 800 minus 20Q. I'll give you the total cost function is going to be 100 plus 20Q. So what I need you to do is tell me what is the profit maximizing quantity. Profit, not revenue maximizing. So go ahead and work that for a minute. All right. So the first thing you've got to, what do you need to know? What has to be true to find the profit maximizing quantity? What do you have to find? Need the marginal cost. Good. Because you're going to set marginal cost equal to, good, marginal revenue, right? So you're going to do MR equals MC. So we need to know what is MC to begin with. And this one's pretty straightforward, right? Because it doesn't have an exponent. So you know that total cost is going to look, is going to go at 100, and then it's going to go up at a slope of 20, right? That's our total cost curve. And so that slope is the marginal cost, right? You can do it by saying, okay, if I take the derivative, the constant 100 just goes to 0. And then this is q to the 1, right? So I bring 20 down. Then I bring q to the 1 minus 1 is q to the 0. Q to the 0 is just 1. Anything to the 0 is 1. So it'd be 20 times 1 is 20. So to find the profit maximizing quantity, I'm going to set marginal revenue equal to marginal cost. So my marginal cost is 20. My marginal revenue is 800 minus 20Q, right? So then I add 20Q to both sides, subtract 20 from both sides. I get 20Q equals 780. Then I divide both sides by 20, and I get Q is equal to 39. Okay. So, you know, we've really already, we did this math, you know, in chapter 11. The only thing we're doing is we're kind of reversing which line has the squared function. So in chapter 11, the cost curve had the squared function. In chapter 13, the revenue curve has the squared function. But otherwise, the math is the same. It's just, you know, you're just kind of inverting it. So if you can do the chapter 11 math, you can do the chapter 13 math. You just have to remember that because we're doing opposite ends of kind of the spectrum, the relationship between revenue and cost is a little bit different, but it's different in kind of an inverted way. Okay, so now we have Q is equal to Q is equal to 39. So what is the maximum profit? So go ahead and solve for what the profit actually is. And I want to give you guys, you know, while you're thinking about that, I just was looking, and there's 49 of you out there on the Zoom, and I have to say I'm really impressed that you're, you know, you're really making the right choice by disciplining yourself to be here, be with the class, even though we're all distributed all over the place. This is good for you, you know, to 120,000 is too much. This is good for you to participate, right? It keeps you focused. You know, like I said before, it's really important. It's really important when things get kind of crazy to try to keep yourself in some sort of routine. All right, we've got some folks with the right answers, a couple of people off, a little off the path. Good. Okay, the right answer is 15,110. So let's go ahead and plug that in real quick, and then we'll wrap on this. So remember, profit is total revenue minus total cost. So, and we're going to plug in profit at 39. So our total revenue is 800Q minus 10Q squared. So we have 800 times 39 minus 10 times 39 squared. And then our total cost is minus 100 plus 20 times 39. Yeah, right. So we get 800 times 39 is 31,200. 10 times 39 squared is 15,210. 20 times 39 plus 100 is 880. If you resolve that, you get 15,110. Okay. All right, we did a lot of work today. You did a lot of good stuff. Hopefully, you're following along without too much trouble. Just let me remind you, you got the chat function. So, if you're not following something or you're like, hey, I'm lost, you can switch to private message and just shoot me a private chat saying, I'm not getting it. Okay. And I will, if you send it to me via private chat, I will not call you out. I will just, say, okay, hey, I've got somebody that wants me to back up, and I'll go ahead and do that. So just, take advantage of that. We don't have, that's one advantage we have by being in this Zoom environment is you can actually send me a private message. Okay, Ariana, I tell you what, I will go over that. Maybe I'll make maybe I'll make a short video on it. But let me see. Real quick, right? If we look at this graph, right, we had our total revenue function. Oh, you're not seeing it. Hang on. Right. So we have, going back to our graph, right, we have the total revenue function is going up like this. And then we have our total cost function. Profit begins when you cross the break-even point where the total revenue starts to exceed the total cost, and it goes up and up and up, right? This gap gets wider and wider and wider, and then at some point it starts to get narrower again. If you look the way I drew it, it's actually not unreasonable, right? This is where revenue is maximized, right? That's the point where revenue is maximized. But this is the point where profit is maximized. So you can see the gap here between at 5, where revenue is maximized, is actually smaller than where profit is maximized. So it really has to do with the relationship between the total cost curve and the total revenue curve, right? It is because we're subtracting total cost from total revenue. At the quantity where total revenue is maximized, total cost relative to total revenue is actually greater than where total revenue is slightly less than its maximum position. So you're not trying to find the maximum revenue, you're trying to find the point where the distance between total cost and total revenue is maximized. So it's a slightly different problem. Does that make sense, Ariana? Okay, good. All right, so we'll call it a day for that. So next time, so on Monday, we will continue with chapter 13. I would encourage you, if you have the time, if you're sitting around being bored at home, go ahead and start reading chapter 13. Do the exercises in the leap leap pad. Get those out of the way. I will be sending you some additional problems. Hopefully tomorrow, some point. I should have enough time to write them up. Okay, so we're going to keep proceeding. So next time we'll still be on 13. Any questions on econ and where we're at right now? I'm going to give the chat just a second to catch up if somebody's typing something. Okay, so otherwise, okay, I'm not seeing anybody asking any questions. So, just email me if you want to talk to me about class or you're having trouble. I'm going to post the video from today's class. And then if you're having trouble, send me a email, and I'm happy to set up a time and we can Zoom privately and go over stuff. Okay. All right. I'm not seeing any questions, so I'm going to stop the recording.